Welcome to the lair of the Batty Boffin.
Hi there Batty fans, time for a little more electricity with the Batty Boffin. In earlier videos we've been talking about circuits like these, and we've had things like ammeters in them and voltmeters to measure the current and the voltage, and we've used a lovely little formula triangle that relates the volts, the current in amps and the resistance measured in ohms. Now, in most of the circuits we've just had a thing like a lamp in there. But what if you have more than one thing? Now, we did brush on that when I measured the voltage drop over two different lamps in the circuit. We saw that when I had two lamps in the circuit, they didn't light as brightly as when I just had one. And this is the kind of thing we've got here. Now, I've used resistances here, marked R1 and R2. They could be lights, they could be motors, they could be anything, but just for simplicity, I'm going to use resistors. And those are components that just have a resistance, that's all they do. So very, very simply, we've got our diagram here, and I'd like you to copy this out. At the top here, I've got a cell. The dotty lines in the middle just mean it goes short, long, short, long, short, long, short, long, short, and lots of them just to save me drawing them. So that's that symbol there, it just means lots of cells. And we have our main current going this way round from the positive round to the negative of the battery, a couple of ammeters in here, a couple of resistors, R1 and R2, and over each resistor is a voltmeter. Remember, of course, that ammeters are always run in series in the main circuit, whereas voltmeters are always wired in parallel. They go over a component. So first thing to do is pause the video and copy that down, please. Right, so let's have a look at working out some of the currents and things for this. If we have a 6-volt battery and we've got two resistors that are, say, I don't know, 100 ohms each. So there's 100 ohms and there's 100 ohms. So they're both the same resistance. What's going to happen there is that they are going to share the voltage. So voltage number 1 on voltmeter 1 would read, that's an ugly looking 3 there, 3 volts. And voltmeter number 2 would also read 3 volts. They're sharing it equally between them because they're both the same resistance. What about the ammeters though? What would they show? Would they be the same or would they be different? Well, in a series circuit like this, they show exactly the same amount. We can work out what that is by using our trusty formula triangle down here. So, something for you to do. The voltage is 6 volts, 6 there, and you can see there's a total of 6 along here. The resistance, we're adding them up, we've got a total resistance of 200 ohms. So, could you work out, please, what the current is? You can pause the video and do that now. Welcome back. Let's have a look. If we want to know the current, we're going to use V over R. So the current is equal to the voltage divided by the resistance, which in our case is 6 divided by 200. 6 divided by 200. Well, 6 divided by 2, that's 3. So that'll be 0.3. So that'll be 0.03. If you're not happy with that kind of math, check out some of the Batty Boffin math videos where we go through questions like that. 0.03 amps, quite a small number, but that's quite normal. You often get milliamps and things in these. So that means that ammeter number 1 will read 0.03. And the other ammeter on the other side will also read 0.03. When things are in series like this, the amps are the same all the way round and the volts get shared out between the things. Now these two had the same number for the number of ohms, but what if they're different? Well, have a look at the next part of the video. See you in a minute. Okay, so here's one for you to try. Now, this might look a little bit complicated, but let's just talk you through it. First of all, we've got our circuit. Here's our cell. And I've got a whole bunch of ammeters all the way through. Ammeter 1, 2, 3 and 4. Okay? And then going around the main part of those things, I've got some resistors, resistor 1, resistor 2 and resistor 3, and over each resistor we've got a voltmeter, voltmeter 1, 2 and 3. So the first thing you need to do is take a good look at that. When I say pause the video and copy it down, probably best to pause the video now while you can see it. So pause the video now and copy it down. Okay, hopefully you've got that all down. Now, since this is a series circuit, we'll remember that the amps are the same all the way through and the volts are shared out. So what you can do, first thing, is just squish all these resistors all together like it's one and work out the total resistance for the whole of the circuit, and with that, once you've got the resistance and you've got the voltage, you should be able to calculate the current. So pause the video and do that now, please. Right, let's work out the current. So we've got our voltage is 6 volts. Our resistance, the total resistance, I'm going to put it RT for total resistance, is 40 plus 50 plus 30. Okay, 40 plus 50 plus 30, that's 3 plus 4 plus 5, which is 12 with a naught on the end, 120 ohms. So with those in mind and using our formula triangle, I hope we remember that. V equals IR. And here we've got the V and we want the R, we've got the V and we've got the R, we want the I. So we do volts divided by resistance. Volts divided by resistance. Okay, so what's that? 6 divided by 120. 6 divided by 12 would be 0.5, so that is 0.05 amps. If you remember, amps often come out to quite low numbers. So that's 0.05 amps, or we can put that in milliamps by moving the decimal point 3 jumps. 1, 2, 3 over that little naught that's there. 50 milliamps. Okay, so that's the current that's flowing. And we did that by just regarding all those 3 resistors all as one big resistor, and we worked out the current flowing. And since it's in series, the current is the same all the way through. So ammeter 1 will read 50 milliamps, ammeter 2 will read 50 milliamps, ammeter 3 will read 50 milliamps, and guess what ammeter 4 reads? Yep, 50 milliamps. So that's the amps. They're the same all the way through. The volts, on the other hand, are shared out, and they're shared out in ratio. If you're not happy with ratio, check out some of the Batty Boffin maths videos where we go through that on here. But what we've got are 3 resistors, and we need to share out 6 volts between them. So we can do this just by doing V equals IR over each one. So off you go with the first one. You've got resistance is 40. The amps are 0.05. Put it in amps, not milliamps, and you should be able to calculate the voltage drop over that first one. So have a go at that one now. Right, we've got a V, which we don't know. I is 0.05 and R is 40. Okay, so using this version of the formula, V equals I times R, voltage is 0.05 times 40. 0.05 times 40, what's that going to be? Well, 0.5 times 40 would be 20, so that'll be 2. 2 volts. Yep, that seems reasonable, doesn't it? Happy with how we did that? We did volts equals amps times ohms, and just multiplied those together. So you can pause the video and do the next 2 now. Okay, here's the answers we should have. Using exactly the same formula as before, voltage 2 is the current, which is the same, times this resistance, 50 ohms. So 0.05 times 50, which comes out to 2.5 volts. And for voltage 3, we used the third resistance. So here's our I times 30 ohms, and that comes out to 1.5. And just for a check, 2 volts plus 2.5 volts plus 1.5 volts comes to 6. That's important. So that means that this resistor here is dropping 2 volts from here to here. So that would, from here to here is a 2 volt drop. From here to here, the bigger resistance has got a 2.5 volt drop, and this one, the smaller resistance, has got the smallest voltage drop, 1.5. But all together they're sharing out the 6 volts. There, hope you enjoyed that. Come back to the next video and we'll look at things wired up not in series, but in parallel. See you next time, Batty fans.